What is the strangest thing humans have found on the moon? It's not aliens, nor is it a base, but rather something that shouldn't exist at all. With the unveiling of our crude lunar lander, this discovery has become critically important. It's been more than half a century since Apollo astronauts last set foot on the moon over 50 years ago. Since then, no human has walked on that land again, but dozens of probes have been sent there. Some have landed successfully, while others have orbited the moon. There were even probes deliberately crashed into the moon just to see what kind of splash they could make. All in all, the moon is the celestial body that humanity has played with and studied the most. But even after decades of research, the moon is still full of mysteries, whether it's the way it stores heat, the principles behind how it conducts electricity, or even the properties of its soil. What we know is still far too little. The universe seems to be like this. The more we study, the more problems we discover. For example, before we had lunar soil, there was so much anticipation, but after bringing it back, scientists kept finding chemical traces that shouldn't exist, leaving them scratching their heads for decades afterward. You might think that a scientific discovery would immediately change everything, but in reality, scientific progress is extremely slow. Sometimes, even when everyone notices something, no one believes it. This story goes back to 1976. At that time, the Soviet Union launched an unmanned probe to the moon called Luna 24. This was their last mission to dig up soil on the moon. At the time, no one paid much attention. It wasn't the first mission of its kind, nor was it a large-scale operation, but in fact, it quietly accomplished something significant. The probe drilled about 2 meters beneath the lunar surface, extracted a small section of lunar soil, and brought it back to Earth. This sample weighed only about 170 grams in total, roughly the size of a baseball. Although it wasn't much, something strange was found in this narrow tube of lunar dust, a trace of water. About 0.1% of the sample contained water, and the deeper you studied the sample, the more water you found. This should have been a big deal. But on the contrary, scientists believed that this water might have come from Earth, that the sample had been contaminated, perhaps by the lander or by equipment from Earth, because the textbooks clearly stated, the moon is dry and there can't possibly be any water there. And this wasn't the first time either. Previously, the soil brought back by American Apollo astronauts also contained similar hydrogen signals, but those were likewise dismissed as contamination. So these clues, which should have caused a huge stir, ended up gathering dust in the corners of lab reports for decades, with no one mentioning them again. It wasn't until the turn of the century that people started to realize, had we missed something important? But by the time we were ready to go back and take another look, the moon was already prepared to present us with even more challenges. If you were dropped on the edge of some craters at the moon's poles, you would witness a scene that seems almost unnatural. It's not because there's something there, but rather because there's absolutely nothing, not even light. There's only a region of perpetual shadow that hasn't shifted for billions of years. These areas are called permanently shadowed regions. Why does this happen? Because the moon stands almost perfectly upright, with an axial tilt of only about 1.5 degrees. This means that when sunlight reaches the poles, the rays sweep almost horizontally across the lunar surface. The craters are large and deep, so sunlight can't reach inside. As a result, those places have barely seen a trace of sunlight throughout the entire history of the solar system. Not only is it cold, but there's no heat circulation. The coldest spots can reach temperatures below -240 degrees Celsius, which is even colder than distant Pluto. You could say these are the coldest places in the solar system. Back in the 1990s, scientists began to wonder if a comet or asteroid had ever collided with the moon. If water was brought over, could some of the water vapor have drifted into these craters and then frozen, never to leave again? This idea immediately caught fire because it meant the moon might not just be a dead rock, it could actually be a resource depot, a future refueling station. From then on, everyone's attention was focused on the moon's poles. Just observing from Earth was no longer enough. We had to get closer and see for ourselves. But the problem is, these most promising spots are also the hardest to reach. The terrain is complex and there's no sunlight, so solar panels are basically useless there. Still, the temptation is just too great. What if there really is ice? And so wave after wave of exploration missions set out. There was only one goal, to find solid evidence. But just then, things started to get strange again. Scientists suspected there was ice there, so the next logical step would be to send a scout to take a look. However, landing directly was too risky. So, the first few missions just orbited above to observe. The first was NASA's Clementine, launched in 1994. It wasn't sent to look for water. Its main mission was to map most of the moon's surface and confirm that there really are those permanently shadowed craters at the South Pole. But it didn't carry the right instruments, so it couldn't confirm whether there was actually ice in those shadows. By 1998, NASA launched the Lunar Prospector, this time specifically to search for water. It used a special instrument to scan the moon, and as a result detected a large amount of hydrogen signals at both poles, especially in those shadowed regions. This made the scientists overjoyed. Theoretical estimates suggested that the ice reserves there could be tens of millions or even hundreds of millions of tons. This isn't just a puddle of water, it's a discovery that could change the global landscape. But here's the problem. Detecting hydrogen doesn't necessarily mean water has been found. It could also be part of hydroxyl. Or it could be locked inside minerals. The instrument can't distinguish between these possibilities. It can only tell us that there are hydrogen-containing substances there, but it can't confirm whether this hydrogen is part of water ice. So what exactly is it? In fact, even the Lunar Reconnaissance Orbiter can't see it, so it's not really solid evidence. This has left the scientific community scratching their heads once again. There is data and there are clues, but there's just no way to make a final confirmation. It's like the moon is telling you it has a treasure but just won't let you take a peek. So scientists thought, if we can't see it clearly from above, why not just go for it and crash something into it? You heard that right. They decided to crash into the moon. The logic is simple. If the ice is hidden at the bottom of a crater and I can't see it from above, then I'll just smash something into it really hard. Blast the stuff at the bottom of the crater out so it flies into the sunlight, then I'll be able to see it clearly, right? This method is simple, direct, and effective. The first attempt came from the Lunar Prospector. After completing its mapping mission, it crashed into a crater near the moon's south pole in 1999. But unfortunately, this attempt failed. No water was detected, and the results of the experiment remain inconclusive. Some said the impact angle was wrong, others said the collision wasn't forceful enough. 10 years after the failed impact experiment, in 2009, NASA's L-Cross mission brought a turning point. This time they did something clever. They brought a trailblazer along, the rocket stage that carried the spacecraft into space. First, they used this massive hunk of metal as a projectile, smashing it into a crater near the lunar south pole called Cabeus. A few minutes later, the main L-Cross satellite itself followed the same trajectory, flying directly through the debris cloud created by the impact to conduct on-site analysis. This time it worked. The onboard instruments detected water vapor in the debris cloud, not just a hint, but real, measurable water. There were also substances like methane and ammonia. This was a first for humanity. We had truly, tangibly found water on the moon. This made headlines all over the world. Scientists popped champagne to celebrate, feeling that this decades-long mystery had finally been solved. But soon, new questions arose. The impact had revealed water, but just how much was there? Was it solid ice, or was it mixed in with the lunar soil as icy grains? Most importantly, is this stuff easy to extract? The L-Cross mission gave us the answer, but the probe itself was destroyed in the impact and couldn't provide any more information. All we knew was that there was water at that specific spot, but the overall picture of the moon remained a mystery. All along, people have had a pretty straightforward idea. If there's water on the moon, it must be hidden in those coldest, darkest, permanently shadowed regions. These places never see sunlight, like natural deep freezers where ice can stay preserved for billions of years. The logic is sound. But the moon always manages to surprise us with something new. Orbital probes like NASA's Lunar Reconnaissance Orbiter, which has been circling the moon since 2009, and India's Chandrayaan-1, for example. They started detecting faint signals of water molecules not just in those deep freezers, but also on the sunlit surface of the moon. This really left everyone baffled. Finding water in places exposed to sunlight, where daytime temperatures can soar above 100 degrees, shouldn't all the water have evaporated long ago? And what's even more puzzling is yet to come. Scientists discovered that these water signals aren't always present. They actually seem to follow a schedule. At noon, when the sun is at its strongest and the surface is hottest, these water signals weaken or even disappear completely. But come evening, as the ground cools down, the signals return. What's going on here? Is the moon sweating? Does it sweat under the heat of the day and then take it back at night? This phenomenon completely overturns our understanding. You have to remember, the moon is in a vacuum environment. There's no atmosphere, no air pressure, and certainly no wind, rain, or lightning. On Earth, water evaporates and condenses to form clouds and rain. That's called the water cycle. But the moon is barren and bare, so where would a water cycle come from? This is definitely a top-level mystery that the moon has thrown at us. So where does this water come from? Scientists have scratched their heads and come up with a few possibilities. One theory is that it's delivered by visitors from outer space. Every day, countless tiny meteorites like specks of dust crash onto the moon. They might carry a bit of water themselves, or when they smash into the minerals in the lunar soil, they could knock loose water that's trapped inside. Another theory is even more interesting. It suggests that the water is blown in by the sun. The sun is constantly blowing outward. One type of charged hydrogen particle, which we commonly refer to as the solar wind, is constantly blowing. When this wind hits the moon, the hydrogen particles collide with the oxygen in the lunar soil, and right there on the spot, they synthesize water molecules for you. No matter what the source is, this discovery has completely changed the game. It means that we might not have to go to those dark, cold, and extremely difficult to develop polar craters anymore. Perhaps the entire lunar surface is lightly moistened with a thin layer of water. It just depends on whether we have the ability to collect it. With this, the possible locations for future lunar bases have instantly multiplied many times over. This tantalizing possibility directly gave rise to the next generation of exploration missions. So in 2023, Indian scientists also took on this ultimate challenge. The Chandrayaan-3 lander targeted the lunar South Pole, which scientists believe is the area with the highest concentration of frozen water on the moon. This was the first time humanity had sent a probe to the South Pole. Everyone watched with wide eyes, waiting for the lunar rover Pragyan to send back news that it had found ice. The rover set off using lasers and X-rays to analyze the soil everywhere. The results? There was aluminum, iron, calcium, sulfur, everything except hydrogen. No hydrogen means no water. Suddenly everyone was stunned. Where was the promised water? It was clearly marked on the map. Had we been wrong all along? Or was the water buried too deep for the rover's little scoop to reach? Before anyone could figure it out, the 14-day-long lunar night arrived. The temperature suddenly dropped to over 100 degrees below zero, and Chang'e 3 couldn't survive. It fell into an eternal sleep. What it left us with was an even bigger mystery than before. But Chang'e 3's journey wasn't in vain. Before its sacrifice, it accidentally discovered a crucial clue with a temperature probe. It measured the temperature of the lunar soil and found that the surface, baked by the sun, was scorching hot, over 60 degrees Celsius. But as soon as the probe was inserted just 8 centimeters below the surface, the temperature suddenly dropped to minus 10 degrees. That's an enormous temperature difference. What does this mean? It means that the very top layer of lunar soil acts like a thick insulating blanket, so the heat from outside can't penetrate at all. This perfectly explains why the lunar rover found nothing on the surface, because the water ice is very likely hidden just a few centimeters beneath this down jacket layer. It's hiding there safe and sound, so it's very likely that it's not that there's no water, but rather that our previous shovels were simply too short. So the question is no longer whether the moon is dry, but whether our tools are sharp enough. We just haven't been able to dig deep enough yet. If this is true, then the next lander won't need to fly farther or see more clearly. It will just need a more powerful drill. For decades, the search for water on the moon has been seen as a scientific curiosity, a way to better understand the moon's history, its geology, and how water moves throughout the solar system, but that's no longer the main reason people are interested in it. Today, lunar water means something much more immediate, a springboard for humanity's journey into deep space and the cornerstone of future space bases. Because if we can find usable water on the moon enough to extract, purify, and store, it could unlock everything else. First of all, it would make long-term lunar missions possible. Water is heavy, and launching it from Earth is extremely expensive. Transported water is as valuable as gold, but if astronauts can source water locally, they can reduce the amount of supplies they need to bring. This water could be used for drinking, cooking, cleaning, or cooling equipment, without relying on constant resupply from Earth. Secondly, water can be split into hydrogen and oxygen, which is the same fuel combination used by many modern rockets. If we can establish a system to extract water ice and convert it into propellant, then the moon becomes more than just a destination. It becomes a refueling station, a place where spacecraft can stop on their way to deeper space, Mars, asteroids, or even farther. A place where you can refuel before continuing your journey. This changes the entire equation. Currently, every mission has to carry all its fuel from the very beginning. But establishing a resource supply base on the moon could lighten the load, and launching from the moon is also easier. Its gravity is only 1/6 that of Earth's, which means less energy, lower costs, and greater flexibility. Spacecraft launched from the moon don't need massive rockets, they just need a push. Third, local water changes the way we build. It can support closed-loop life support systems, recycling waste into usable resources, and it can even help grow food. Some plants can grow in lunar soil under controlled conditions. But they still need water. If we find enough water, future habitats might not have to rely entirely on supply drops or hydroponics. You could say this will play a pivotal role in the future of human space exploration. Although it's still uncertain exactly how much water is available or how easy it is to access, all these fuel-based missions beyond the moon can only happen if we are able to extract that water in the first place. This brings us to the final question. Despite all the mission data and optimism, the truth is we still don't have a clear picture. Every time we feel like we've figured out the moon, it surprises us with something new, a contradictory reading, a missing signal, an unexpected result, and this pattern keeps repeating itself. From orbit, we've detected strong hydrogen signals, but when we land, there's no hydrogen in the soil. We've found signs of water vapor in the plumes from impact events, but there's no frost, no ice caps, no visible accumulation, even in craters that have never seen sunlight, places cold enough for ice to remain frozen for billions of years. High-resolution cameras still haven't captured anything that clearly looks like ice. Instead, what we get is ambiguity. Shallow probes find nothing. The water detected by instruments seems to disappear during the day. Rovers drive through craters that should be filled with frozen material, only to find more dust. Even new technologies like shadow cameras, despite their ability to image the darkest places on the moon, still haven't revealed what scientists were hoping for: clear, reflective chunks of ice. This raises a troubling question. What if we've been wrong all along about how water is stored on the moon? What if the models need to be revised? Or even worse, what if water does exist, but it's so sparsely distributed, buried so deep, or chemically bound so tightly to the soil that we're simply not ready to extract it yet? Of course, looking on the bright side, maybe it's just that our tools, though precise, aren't quite good enough yet. Our orbiters are like eyes hanging in the sky. They see a lot but can't actually touch, unlike landers and rovers. It's like reaching out with your fingertips. You can touch, but you can't dig deep. All our explorations feel like scratching an itch through a boot. It always seems like we're just a little bit short, and even the spectral data we get back is full of riddles. It tells us there's hydrogen here, but doesn't say whether it's the hydrogen in water or in rocks. It tells us this area is very bright, but doesn't say whether the brightness comes from frost or some special kind of mineral. Yet it seems like the word "give up" simply doesn't exist in the human dictionary. On the contrary, the heavier the fog, the more our curiosity is ignited. New missions are lining up, stronger landers are being built, and everyone's eyes are still fixed firmly on that place. That place where we firmly believe treasure is hidden. Perhaps the next mission will bring along an even more advanced Luoyang shovel. It will come equipped with a deeper drill and a smarter extraction system, no longer just probing but aiming to break through that final barrier once and for all. From beneath that insulating lunar soil, we will scoop up a handful of a cold and solid future. Of course, the moon might play another trick on us, revealing even more unsolved mysteries. And when our Luoyang shovel finally lifts up that handful of cold and solid future, an era even grander than the moon landing itself will begin. By then, this blue planet beneath our feet will no longer be the cradle of civilization, but the harbor from which we set sail toward the sea of stars.